Today's urban landscape is a monument to technological innovation. We live, work, and travel surrounded by high-strength, high-tech materials, all intended to make our lives more comfortable and secure. But when something goes wrong, an act of nature, a consequence of our own making, or an event that simply defies explanation, these same materials can quickly become barriers to our very survival. No one is more aware of this than today's fire and rescue professionals.
Yeah, a lot of twisted steel and a lot of sheet metal, a lot of stainless steel.
Rows upon rows of studs and metal lockers and desks. Anything that you typically find in an office building, kind of smashed and thrown in a big pile. We were cutting through it.
You're working in very restricted areas where you can just about move. And you need a good tool that's going to work in those situations that basically is not going to produce a lot of carbon monoxide.
There are not many tools, not many, at least not yet, developed just for the fire service. So we go where the tools primarily have always been used, and that is in construction.
More and more, rescue workers have come to rely on portable electric power tools, originally designed for the construction industry, but adapted for search and rescue applications.
We're carrying them more frequently on our rescue trucks. So whatever call we are called to, we're not trying to make a tool fit. We have the correct tool for the job.
Whether it's a small vehicle extrication outside of some intersection or somebody who's got their hand caught in a factory in some machinery. You know, those little tools play a big role in what we do every day.
Like any tool, however, the effectiveness and safe operation of these portable power tools depends on the knowledge and skills of the person using them.
Everybody knows how to use this drill, they know how to use that saw, they know how to use it because it's just a matter of turn on the switch. If power is there, the tool will do the job. But that's not true. It really takes the people have to learn how to use the tools properly. First, from the safety aspect, because all these tools have a potential danger to them when used incorrectly. And the second is that there's a lot of wasted effort if you don't use the tool correctly, because the tool doesn't get an opportunity to do what it's designed to do.
Every rescue situation is, of course, unique. But in most cases, it will be the material being cut, combined with the environment in which you are working, that will determine the best tools to use.
There's a lot of rescue operations where the rescuer is having to do it vertically above his head, and he's having to do it laying on his back, or he's having to do it crawled into tight spaces.
If you get too big of a tool, you run into a situation where it becomes cumbersome how long you're going to be using that tool. If you get the biggest saw you can find on the stack, but if you're going to be cutting for hours on end, that's not the best tool for the job.
The material rescue workers encounter most often is metal. Often it'll be in the form of a crushed vehicle. But at one time or another, you may be challenged to cut your way through everything from rebar to refrigerators. Probably the most versatile and widely used metal cutting tool is the reciprocating saw, commonly referred to as a sawzall.
And I guess that's a good term for it, the sawzall, because depending on the selection of the blade that you utilize, whether it be length or teeth configuration, that tool is probably proven to be one of the most popular and most efficient and most productive tools for the rescuer to use in almost all elements of rescue.
We use sawzalls in motor vehicle extrication to remove doors, to cut hinges, to remove roofs, A post, B post, C post, and so forth, bus extrication. You can use, there's a wide range that you can use this tool for, providing you use it properly.
Reciprocating saws are not difficult tools to master. But to use them to their fullest advantage, there are a few simple rules you need to follow. First and foremost is choosing the correct blade for the type and thickness of the material being cut. While there are many different types of reciprocating saw blades on the market, only demolition-grade blades are durable enough for rescue work. These blades come in two basic types and with varying numbers of teeth per inch, or TPI. For example, a 10 to 14 TPI metal cutting blade, like Milwaukee's Torch, is the best choice for automobile A and B pillars, body panels, or nader bolts. This blade is also ideal for cutting rebar. For thinner metal, such as HVAC ductwork, metal studs, or sheet metal, you'll get better results with a finer 18 TPI metal cutting blade. General-purpose demolition blades, like Milwaukee's Axe, have much coarser tooth patterns and are intended for thicker, less dense materials like wood or plaster. But with their extra rigidity and pointed tips, these blades can also come in handy when you have to penetrate a sheet metal surface. Another thing to remember is that because of their short blade travel, only a small section of reciprocating saw blades do all the cutting. When a blade begins to dull, readjusting the shoe position will allow fresh teeth to be used. Also, don't forget that reciprocating saw blades are reversible. It's worth taking the time to flip them over when you're in an awkward cutting position.
Depending on the blade that's inserted into that saw, you can cut just about anything, whether it's metal, wood, or whatever.
The two other reciprocating saw features you need to be aware of are variable speed and orbital action. Blade speed is controlled either by the amount of pressure applied to the trigger or on some models with a speed control dial on the handle grip. These controls are there for a reason. Faster is not always better. Higher speeds are fine for wood or other less dense materials, but for metal, you'll actually cut faster and have more control using a slower speed setting. The second control feature, orbital action, is available only on some reciprocating saw models. While selecting this mode will increase the tool's efficiency when cutting wood, for metal, always leave it in the reciprocating position. Reciprocating saws are available in both corded and battery-powered models. Each have their advantages, depending on the rescue environment.
When we were at the Pentagon, the battery power tools were very effective. You don't have cords laid out for people to trip on, and typically we were standing in anywhere from an inch to 8 or 9 inches of water, and a 110 volt system was not necessarily the best application for that environment.
While reciprocating saws can and often are used to cut just about anything, in some situations, a circular metal cutting saw is a better choice because it will allow you to control cut depth. This can be a big advantage when cutting away vehicle or aircraft body panels. And while these tools may look like circular wood saws, don't be fooled by their appearance. When used properly, even this battery-powered model, which uses the same battery packs as cordless sawzalls, can cut through steel plate.
Battery technology has really advanced itself to where it's very efficient. However, you have to have knowledge of the proper techniques and proper usage of that tool in order for that battery technology to be as efficient as it's designed. You can waste a lot of effort, and if you're wasting the effort actually not applying the force in the manner that you're supposed to, then you're losing that battery power rapidly. But the battery-powered tools that are out there today really do a fantastic job in the rescue arena. For example, the Power Hawk.
Similar to the hydraulic jaws of life, but powered instead by a 12-volt battery pack, Curtiss-Wright's Power Hawk is the only tool we'll be discussing specifically designed for rescue work. There are 3 attachments for this tool you need to be familiar with, as each is intended for a different type of cutting or spreading. The cutter blade, for example, is designed primarily for cutting automobile A and B posts, but it can also be used to cut nader bolts or any other type of fabricated steel. For more general-purpose cutting, including plate steel up to a 1/4 inch thick, switch to the straight power blade. By attaching the spreader arm, the tool can be used for prying open doors, hoods, or removing body panels. There's also a pusher ram accessory for use with the spreader arm that can be used to roll automobile dashboards or for any type of jacking or stabilizing.
It can be used in confined spaces. The fact that we are not generating CO with a combustible power source, the fact that it is also very lightweight, and that improves the dexterity of the rescuer. The Power Hawk has proven to be one of those tools that really fits those confined spaces and has enhanced our ability to do the job.
And PowerHawk's rechargeable power packs can also be used to power any 18-volt cordless Milwaukee tool.
Take the Sawzall, for example, the 18-volt Sawzall, and run it off of their battery technology. It gives us enhanced lifespan of the use of that tool, where we were maybe swapping out batteries on a regular basis of maybe every 15 or 20 minutes if we were really working the tool very heavy under rescue conditions. Now we get quite a duration out of those battery packs, and it really enhanced the operation of that tool.
While most day-to-day rescues will involve automobile accidents and residential fires, the uncertainty of today's world demands that rescue professionals be prepared for virtually any eventuality.
In a collapsed structure, everything that's collapsed in that collapsed structure is still a danger because it can collapse farther, and it can pin and trap the firefighter. We have to basically go into a demolition mode, but we have to do it in such a manner as we have control over that structure. So that's where these portable tools actually make the firefighter or the rescuer very efficient in doing that.
One of the most difficult materials you'll encounter in a structural collapse is reinforced concrete. You either have to breach your way through it or move it out of your way. And in either case, your first step will be to bore holes. Holes for setting anchors. Larger holes for inserting cameras or listening devices. And multiple holes around the perimeter of a breach. In almost all cases, the tool you will reach for first is an electric rotary hammer. Because these tools have two operating modes, hammer only and hammer with rotation, they can be used for both drilling and chipping. This means one less tool to drag behind you into a collapsed structure. But you have to make sure you select the correct operating mode. For drilling, always set the tool to hammer with rotation. Rotary hammers come in different sizes and with different types of chuck systems. The most common chuck types are spline, SDS, and SDS Max. Where it can get confusing is that each type requires its own style of bit.
Well, all of these things are not interchangeable. And a lot of times those people that pick up a drill and pick up a bit, they don't look at the tail end of that bit to see if it really fits in that drill.
A simple way to avoid any confusion is to mark the tools and their correct bits with paint or colored tape. Standard 4-cutter bits are your best choice for most of the holes you'll be drilling in concrete. For larger holes, like those for inserting a camera, for example, you'll need to use either a core or turbo tunnel bit. Core bits allow you to bore holes as large as 6 inches in diameter. But you'll have to stop periodically and clear the core from the hole. Turbo tunnel bits, on the other hand, are self-clearing, which makes them a better choice when the concrete is more than a foot thick. If you determine that you can safely perform a dirty breach, the first step will be to score the concrete around the perimeter. A large gasoline-powered cutoff saw will be your fastest option, but only if you're working outside. In confined spaces, where carbon monoxide is a hazard, an electric cutoff saw, fitted with the correct concrete cutting wheel, can be nearly as effective. Once you've scored the perimeter, the concrete's integrity will have been weakened enough to allow you to simply break it out. Using a sledgehammer will be an option if you've got enough room, but an electric demolition hammer may be a better choice. In confined spaces, you'll need to use a rotary hammer to chip the concrete from around the rebar. Then, a reciprocating saw with a 10 to 14 TPI metal cutting demolition blade can be used to cut away the rebar. If, on the other hand, you suspect that a victim is in close proximity to the concrete barrier, you'll have to proceed much more carefully. The first step in a clean breach is to drill a series of holes about 2 inches apart around the perimeter of the area to be breached. Here again, a rotary hammer set to hammer with rotation with a standard 4-cutter bit will be your best tool choice. Then, by changing to a slotted chisel bit and switching to hammer-only mode, that same rotary hammer can be used to break out the web between the holes. But remember, Like with any power tool, you'll get the best results with the least operator fatigue by allowing the rotary hammer to do the work. After you've chipped away all the concrete between the perimeter holes, secure the section you'll be removing and cut away the rebar with a reciprocating saw. In some structural collapses, entire sections of concrete must be lifted out of the way with an overhead crane, and you may be called upon to set the necessary eye bolts, swivels, or brackets for attaching cables. This will again mean drilling holes, and once again, that rotary hammer with a standard 4-cutter bit will be your best tool choice. This time, however, because the holes required for setting anchors are relatively small, battery-powered tools, like this cordless SDS rotary hammer, are an option. Depending on the type of anchors used, a cordless impact wrench can speed up the process by allowing you to tighten anchor bolts faster.
And then ultimately, once we can clear the debris using these construction tools, we'll then use them in more the manner they were intended, and that is we'll build shoring concepts that are much like the construction that held the building up in the beginning.
Typically, lumber used for shoring will first be cut to length at a location somewhat removed from the rescue scene, allowing large table-mounted tools, like this sliding miter saw, to be used. Not only will this saw allow you to cut large quantities of lumber quickly, it has the added advantage of being able to accurately cut the various angles required for shoring construction. For less precise, but equally heavy-duty cutting, a 10 1/4 inch circular saw is a good option. But for thinner stock, you'll be better off with a smaller 7 1/4 inch circular saw.
Typical fire service personnel usually, they're typically going to go for the biggest saw, the biggest drill, the biggest cutter, and that's not always what you need. Based on what you're cutting, the materials you're cutting, how fast you need to cut them, a lot of factors play into selecting the right tool for the right job.
Using too big a tool for the task will not get the job done any faster. It will only wear you out quicker. By now, the benefits of learning to use these tools correctly should be obvious. Less obvious, however, may be the impact improper tool usage can have on the rescue effort and on you.
You have to always remember that most of these blades, the RPMs that they're spinning, 4,000, 5,000, 6,000 RPMs, will take off an arm or a limb before you can say, ouch, it's gone.
They're designed, if they're used proper, to be safe, but when you go into a rescue arena, you're in an environment that nobody ever thought about these tools being used in.
Especially in a confined space, where you're trying to hand a tool to somebody else. Fingers are off the triggers. You got to treat it like it's a loaded gun.
Don't let the stresses of a rescue situation cause you to forget common sense power tool safety.
In order to help anybody else, they've got to stay a part of the solution and not become a part of the problem. And the only way that people can really be safe with power tools if they understand what the tools are supposed to do first, and the limitations of the tools, and the proper operation of the tool.
First, at the fire station, reading all about it, as much as we hate to read instructions, but understanding how it works. Once you've done that, take it out to the drill field where you can use it in the application you think you may want to use it in the real world. And then review it every now and then. Take that tool out every couple of months and re-familiarize yourself with that tool. And that's how you get better at them. Using them every day, on the job, training on the job, and then certainly when that big one comes in, you'll be able to be very familiar with that hand tool.
We at Milwaukee Electric Tool and Curtiss-Wright Powerhawk Rescue Systems respect and admire what you do every day. And we sincerely hope that the information in this video will help make your job a little easier and safer.